probably run across asymptotes at some time before in your math career, but in calculus, one thing we really want to focus on is how asymptotes are related to limits. So that'll be one of our main focuses. But we also want to show you how to find vertical asymptotes and horizontal asymptotes without a graph. In other words, if you're just given the function or just given the equation, how can you find the vertical or horizontal asymptotes? First, vertical asymptotes. And this right here is the key when it comes to vertical asymptotes. Okay? If the limit as x approaches a number from the left or the right gives you an answer of infinity or negative infinity, then you have a horizontal asymptote at that x value. So again, if you are approaching a value, a number, and your answer is infinity or negative infinity, then you have a vertical asymptote. So that's the key you need to see, that when you take the one-sided limit at a value, if your answer is infinity, you have a vertical asymptote. Now, as far as finding vertical asymptotes with an equation, vertical asymptotes can be found at the x value that makes the denominator 0 but not the numerator. So it makes the denominator 0 but not the numerator. So for example, as you look at this example right here, there are two values that will make the denominator 0. Negative 4 is one of them, and positive 1 is the other. However, if you plug in positive 1 into the top here, it also makes the top 0. So 1 is not a vertical asymptote. If you plug negative 4 on the top, you do not get 0. So negative 4 falls in this category of vertical asymptote because if you plug it in the denominator, you get 0, but if you plug it in the numerator, you do not. So this equation would have a vertical asymptote at x equals negative 4. Another way to look at it is if it makes the denominator 0, but you can't cancel that term out, then that's going to be a vertical asymptote. So pretty much with these rational functions, the ones that are big fractions, you either have a whole, in which case you can cancel it out, or you have a vertical asymptote, in which case you cannot. So let's look at these and see if we can find their vertical asymptotes. When we look at A, negative 1 will make the denominator 0, negative 1 plus 1, but it won't make the numerator 0. So negative 1 is a vertical asymptote. It makes the denominator 0, and its term, where it's coming from x plus 1, cannot be canceled out. Now B, the top is unfactorable. The bottom, however, can be factored to be x minus 1, x plus 1. So both positive 1 and negative 1 make the denominator 0, and neither of them can be canceled out, so both of them are vertical asymptotes. So vertical asymptotes at 1 and negative 1. I'm going to add that up there to part A as well. A vertical asymptote at that point. Okay, C, we need to factor the top and the bottom. Okay, x minus 2 cancels out, so that's not going to help us find a vertical asymptote. But x plus 2 does not cancel out, so it will provide us with a vertical asymptote. And if x equals negative 2, then this piece is 0, so we have a vertical asymptote at x equals negative 2. Notice, I didn't even pay any attention to the x plus 4 on top. Making the numerator 0 has nothing to do with vertical asymptotes, except if you're checking because it already makes the denominator. But it's got to make the denominator 0 to be a vertical asymptote. Okay, and finally, D, cotangent x. Well, we're not super familiar with cotangent, but if you're in calculus, you really should be familiar with the unit circle. And the unit circle does talk about sine, cosine, and tangent. So there's a couple ways you could approach this. I would recommend using the fact that cotangent is the same as cosine x over sine x. Then if you know your unit circle, you should know that sine of x equals 0 when you plug in 0 or pi. So if x equals 0 or pi, the denominator equals 0. However, cosine of 0 is not 0, and cosine of pi is not 0. So these two fit the bill for vertical asymptotes because they do make the denominator 0, but they do not make the numerator 0. So if you're in my course, there's some examples you can look at. You can look at the evens as well there if you need more help. But we're going to go ahead and move on to the horizontal asymptotes now. So if you remember, vertical asymptotes happened when you approached a number and your answer was infinity. Horizontal asymptotes are going to happen when you approach infinity and your answer is a number. So as it says here, if the limit as x approaches positive or negative infinity for a function equals L, where L is finite, then y equals L is a horizontal asymptote. So this will be y equals instead of x equals because it's horizontal lines. Now the answer to a limit approaching infinity can be infinity, but if you get that, it's not a horizontal asymptote. There's no such thing as a horizontal line at infinity. In fact, if you get infinity as your limit, it's telling you there is no horizontal asymptote because the line just continues either to grow forever and ever or fall and decrease forever and ever, depending on if it's approaching positive or negative infinity. So the main focus here is going to be on learning how to take the limit as x approaches infinity. So for this first one, the limit as x approaches infinity of 3, well, just think about what 3 looks like as a function. It's just a horizontal line. Well, as you approach infinity, it just stays at 3 forever and ever, so the limit is 3. So that's kind of a trivial case, but this would be its own horizontal asymptote. Okay, now however, limit as x approaches infinity of 2x, well, if x gets huge, then 2x is just going to get huge, and it's just going to go to infinity. If you think about what that looks like, it's a line. Sorry, it should go through the origin. But it just, as we move to the right, as x goes to positive infinity, this graph just continues to grow and grow and grow and grow on up forever and ever. So that's why we say it goes to infinity, because it continues to go up forever and ever. Okay, but just to make a point, if we were asked the limit as x approached negative infinity for this one, then we would be heading this direction and our answer would turn into negative infinity because then it would be decreasing without bound. Next one, limit as x approaches infinity of x squared minus 2x. Well, that's a parabola. So if you just think about what a parabola looks like, as you go to the right, as you head this direction, the parabola just goes up forever, so the limit would be infinity. Now for the fourth example, the limit as x approaches infinity for 2 over x squared. You just have to think carefully about this. I'm going to show you how to do these in the calculator in a moment, but most of these you should be able to do without. The limit as x approaches infinity of 2 over x squared. So 2 is on top and it just stays 2. X squared is on the bottom, and as x goes to infinity, x squared is just going to grow and grow and grow and grow. So the top stays the same while the bottom grows huge. Well, if the bottom of a fraction just gets bigger and bigger, then the fraction as a whole gets smaller and smaller and heads toward 0. So anytime the top is small and the bottom is getting bigger and bigger and bigger, your answer is going to be 0. Alright, I want to show you with this next example how to plug it in your calculator. So let's go to y equals, and we'll plug in 3x squared divided by x squared plus 1. We can go to our table, and I'm going to delete these values. This was from something else. But if we're going to infinity, that means we're going to bigger and bigger numbers. So I'm just going to start with 10, and then I'm going to type in 100, and then 1,000, and then 10,000, and usually by then it's pretty clear. But you can keep going if you need to. So as x gets bigger and bigger, notice my x values go 10, 100, 1,000, 10,000. They're getting bigger and bigger. My y value is getting closer and closer to 3. So my answer would be 3. Now let's go and do that with the bottom one as well. Let's try it with x cubed minus x. Notice I am putting the numerator and the denominator in parentheses. That's a good habit to make sure you don't make any mistakes. So we go to the table, and we have 10, 100, 1,000. Now as x is getting bigger and bigger, y is also getting bigger and bigger. Y goes 4.8, 49.9, 500, 5,000. So when that happens, our limit is infinity because we're growing bigger and bigger and bigger. Now it turns out there's some really nice shortcuts for taking the limits of these things when they're rational functions like this. Sorry, I don't know why that was underlined. So what I'm going to do is go ahead and tell you what the answer to these three are. The top one is going to be infinity. The middle one is going to be negative 2 over 4, which reduces to negative 1/2. And the bottom one is going to be 0. Now what I'd encourage you to do is after I get done giving you a hint, pause this video and see if you can find the pattern to this. And then once you hit play, you'll hear me explain it. But the hint I want to give you is that it has everything to do with the exponents. If you look at the biggest exponent in the numerator and the biggest exponent in the denominator and then compare them, it should give you a hint as to how these are going to go. So if you want to pause it and try to figure it out on your own, now's the time to do it. Okay, so hopefully you figured it out. If you look, what's true for the top one is true for any of them. If the exponent is bigger on top, then your limit's going to be infinity. Again, we're only concerning ourselves with the biggest exponent on the top and the biggest exponent on the bottom. So we have an x squared on top and an x on the bottom. Since the power is bigger on top, we're going to infinity. Or we're going to jump to the bottom one. If the power is bigger on the bottom, again, we only look at the biggest power on top and bottom. If the power is bigger on the bottom, our answer is 0. And finally, in the middle, if our powers are equal, again, just look at the biggest powers, then you use your coefficients in front of those. So on top, we had a negative 2 in front of the x cubed. On the bottom, we had a 4 in front of the x cubed. So that gave us our answer of negative 1/2. So there's a nice way to remember this, at least I think it's helpful, and that's Thibaut or Thibaut. However you want to pronounce it, whatever's easier for you. But if you can just remember Thibaut or Thibaut, then this pretty much tells you the whole rule. The T stands for if the top is bigger, then your answer is I, infinity. So if the top's bigger, your answer is infinity. If the bottom is bigger, your answer is 0. So that's a 0 there. And then if they're the same, you can use the coefficients. But Thibaut or Thibaut can help you remember those rules. Now quickly I want to wrap this up by making sure you understand how this relates to horizontal asymptotes. Okay, so if you look at these three, for example, the top one does not have a horizontal asymptote. Since the answer is infinity, that means we have no horizontal asymptote. Now for the middle one, our horizontal asymptote is at negative 1/2. For the last one, our horizontal asymptote is 0. If you look back at our previous examples, this one has a horizontal asymptote at 3. This one has none. This one has none. This one has one at 0. This one has one at 3. And this one has none. My last piece of advice to you is to be careful if the limit is approaching negative infinity. So for example, if I have a question like this. It actually knocks out 2 tricks I can teach you with one example. When you're looking at the powers, that denominator, you should actually treat it just like it's x. Because that x squared is inside of a square root, it ends up working just like an x. So you treat that like x on top and x on the bottom. So those powers are the same top and bottom. So you would just go with the coefficients, which are 1. But you have to be careful about your signs, and that's because we're approaching negative infinity. Well, on top, you'd be plugging in things like negative 10, negative 100, negative 1,000, so you're going to have a negative on top. But as you plug it in here, you're going to be squaring that number. And if you square negative numbers, they turn into positive numbers. So you have a positive 1. So your limit in this case would be negative 1. So just be mindful of that when you're plugging in negative infinity, to look carefully at your exponents and how they would affect those negative numbers.